watch this experiment and then try to guess what happened if I blow air over the top of this paper. By the way, this is a blower. Can you guess what is going to happen? Let's do the experiment. Okay, this is the blower and I blow air over the top of the paper. Alright. I can also blow air with the help of my own mouth. Okay, what did you observe? You have observed that when you blow air over the top of the paper, instead of air pushing down this paper, there is a generation of lift. The paper is being lifted. Do you know why? It is because of the Bernoulli's principle. You know, when I blow air over the top of the paper, the velocity of the air increases. So when velocity of the air increases, the static pressure decreases. Now below this paper, the static pressure is more. Above this paper, the static pressure is less. Now there is a difference between the static pressures above and below. That's why this is being lifted. What is the direct application of Bernoulli's principle? Thanks to this Bernoulli's principle, because of which millions and millions of customers or passengers are able to fly an aeroplane every day. Let's look into the illustration. All right, let's look into this illustration now. As I mentioned during the paper lifting experiment, a direct application of Bernoulli's principle can be seen in how aeroplane wings generate lift. The wings are designed with a curved shape. So I'll show you the actual image of the wings shortly. So in this illustration, the yellow part represents the aeroplane wings. The blue dotted line shows air moving over the wings, and then the red dotted line shows air moving below them. The air flowing over the curved surface of the wing travels a longer path and moves faster, which reduces the static pressure below the atmospheric pressure, as I already explained on the paper experiment. So meanwhile, the air flowing beneath the wing moves a relatively straight path that you can see on the diagram. So at a slower speed, resulting in higher static pressure than atmospheric pressure. This pressure difference creates lift on the aeroplane's wing. Okay, now let's look into the real footage. So this is the aeroplane and you can see how wings are curved. So on the upper side of the wing or over the wing, there is an increased air velocity. So that leads to lowering of the static pressure. But below the wings, there is a higher static pressure as compared to atmospheric pressure. So above, lower pressure or lower static pressure, below, higher static pressure, and now this creates difference in the pressure, right? So that is why there is a generation of lift on the aeroplane.